Hello students, in this video we will be solving the last three problems of exercise from exercise 8.4 under question 5. We need to prove sin A plus cosec A whole square plus cos A plus sec A whole square equal to tan square A plus cot square A. Let's begin from the left hand side. Our left hand side is equal to sin A plus cosec A whole square plus cos A plus sec A whole square, and this is A plus B whole square. So we'll open this up and we'll keep this sin square A plus 2 sin A cosec A plus cosec square A. Next we have plus cos square A plus 2 cos A sec A plus sec square A. So I've just put the A plus B whole square formula. Now we've got sin square A and we've got cos square A. Together they will become 1. So we've taken care of these two. Next we have 2 sin A and cosec A. So sin A, I'll write it this way, but cosec A can be written as 1 upon sin A. These two will cancel here and we'll be left with only 2 over here. We'll proceed further now and we'll keep cosec square A the way it is right now, the way it is. Cos square A is gone from here, and this 2 cos A multiply with sec A will convert to 1 upon cos A. Again this 2 will cancel, we will be left with 2 again, and here we will keep this as sec square A. So now we are left with 1 plus 2 from here plus cosec square A plus 2 from here plus sec square A. So that becomes 2 plus 1 3, 3 plus 2 5. So 5. Now we have over here cosec square A and sec square A. So that we can convert it into some other form. So in which form can we? This is some identity we can get. Let us recall that identity. First we'll draw a regular hexagon. Okay, that actually gave us that identity. This is, we are drawing our regular hexagon, and let's see what our regular hexagon gives us. We have sin A here, cos A here, then you have tan A here, cot A here, and this would be our cosec A opposite to sin A, and sec A if you recall. And we'll put a 1 in between. So we'll connect them first. We have connection over here. We'll put a 1 in between. Now we are interested in cosec square A. Where is cosec? Here. Okay. Cosec square A over here. Now if you recall, we had established some relationship over here. What was that relationship? We had sin square A plus cos square A equal to 1. Okay. This is the way. This triangle, we'll focus on this triangle, we'll focus on this triangle, and then we'll focus on this particular triangle. Now in this triangle, forget about this triangle, we look at this triangle. We get 1 plus cot square A equal to cosec square A. So which is 1 plus cot square A equal to cosec square A. Then if we come to this particular triangle, we get tan square A plus 1 equal to sec square A, right? So we can use that now. See, this was in this direction. Remember the arrows? Yeah. So cosec square A can be written as 1 plus cot square A. We are interested in getting this 7 somehow. So the more number of ones we get, the better it is, till it comes to 7. The cosec square A is equal to 1 plus cot square A. plus sec square a, we can write as 1 plus 10 square a. 10 square a plus 1 or 1 plus 10 square a is the same. So now we have 7. 5 plus 1 6, 6 plus 1 7. 7 plus cot square a plus 10 square a. And if you notice, we have actually arrived at our right hand side. See, easy it was. It was important for us to know the identity. See, once we applied the identity, we instantly arrived at the right hand side from here. It was simple. We broke it, we applied the a plus b whole square formula first, got rid of whatever was possible, like when we say got rid of it, we shortened it, sin square a plus cos square a we got equal to 1, and then we had this sin a cosec a cancel each other out to be left with only 2. Similarly, same thing we did over here, 2 cos a sec a cancelled out to give only 2. So we have 2 plus 2 4 plus 1 from here 5, and then once we had 5 over here, we had to just negotiate or get deal with cosec square a sec square a, and we applied the identity that we learnt in our previous videos to arrive at our final solution. So this is how we could prove it. Our next problem is cosec a minus sin a into sec a minus cos a needs to be proved equal to 1 upon tan a plus cot a. Let's begin with the left hand side. Left hand side equal to cosec a minus sin a whole thing into sec a minus cos a. I'll convert this cosec a into sin a and sec a into cos a first. So 1 upon sin a minus sin a into 1 upon cos a minus cos a. I'll take the LCM. So we'll have 1 minus sin square a upon sin a into 1 minus cos square a upon cos a. Okay, so 1 minus sin square a, we know it is cos square a. Divided into sin a multiplied by 1, and 1 minus cos square is sin square a to cos a. You can write it over here, that 1 minus cos square a equal to sin square a, giving a reason 1 minus sin square a equal to cos square a. Close the bracket. So now we have cos square a upon sin a and sin square a upon cos a. We can cancel out 1 cos a and 1 sin a, and we'll be left with cos a sin a over here. Okay, so we have cos a sin a left on the left hand. Now we'll take the right hand side. Okay, so I'll do it over here. The right hand side says what? 1 upon tan a plus cot a. Okay, that is our right hand side. So I'll convert this into sin and cos. 1 upon sin a upon cos a plus cos a upon sin a. I'll take the LCM and we'll see what we get. So this will become sin square a plus cos square a whole thing upon sin a cos a. So sin square a plus cos square a will become 1. So we have 1 upon 1 upon sin a cos a. Okay. Now we convert this into multiplication. So 1 upon 1 into what is the denominator will become now the numerator, and the numerator will become the denominator. So we are left with sin a cos a. Okay. So both sides we are left with sin a cos a. We can say therefore LHS is equal to RHS, and that's how we prove them equal to each other. A final problem of this particular exercise and also of this chapter is we need to prove 1 plus tan square a upon 1 plus cot square a equal to 1 minus tan square a upon 1 minus cot a, the whole square, and that needs to be proved equal to tan square a. So actually we need to prove these equal to each other, and to do so we need to prove this one equal to tan square a and this also equal to tan square a. Well, let us first begin with our left hand side. This will become our left hand side, this will become our right hand side, and both need to come equal to tan square a. Let us see. So left hand side equal to 1 plus tan square a upon 1 plus cot square a. I'll convert this into sine and cos. So 1 plus sine square a upon cos square a whole thing upon 1 plus cos square a upon sine square a. So I'll take the LCM next. So that will be cos square a plus sine square a upon cos square a whole thing upon sine square a plus cos square a upon sine square a. Then this will become 1 upon cos square a whole thing upon 1 upon sine square a. Next, I'll complete it over here. Left hand side equal to, now we'll convert it into, from division to multiplication. So this will be 1 upon cos square a multiplied by, what is the denominator will become the numerator. So denominator was sine square a, now it is the numerator, and 1 was numerator, so now it has become denominator. So we are left with sine square a upon cos square a, which is equal to tan square a. So we've got left hand side equal to tan square a. Now let's try to do the same with right hand side, which is equal to 1 minus tan a whole thing upon 1 minus cot a whole square. So let us try to simplify this by bringing it into sine and cos form first. 1 minus sine upon sine a upon cos a, whole thing upon 1 minus cos a upon sine a. Now I put the bracket to the square, take the LCM inside, we get cos a minus sine a upon cos a whole thing upon, equal to sine here, sine a minus cos a whole thing upon sine a, put this in the bracket, whole square. Fine. Now without opening the bracket, okay, without opening the bracket, what I'll do is from division I'll convert it into multiplication form over here. So this will be cos a minus sine a upon cos a, and the denominator will now become the numerator, and numerator will become now the denominator. If you, and this whole thing will be square like this. Now if you notice carefully, we can actually cancel these two terms, except for the fact that here we have cos as positive, here it is negative, and here it is negative for sine a, and here it is positive. So what we'll do is we'll take this negative sign out from here. When the negative sign gets out from here, it will become positive because this square is here. Okay, I'll show you what happens then. So I'm trying to match this with this so that I can cancel them out. Right hand side equal to sine a minus cos a upon cos a into sine a upon sine a minus cos a, whole thing squared. Now these two will cancel, we are left with sine a upon cos a whole square, and sine upon cos a is what? 10a whole square. This is equal to 10 square a. So therefore we can say left hand side is equal to right hand side. That's how we prove the identity. Okay, so remember, only thing to remember is this negative sign I've taken common, which means I've taken it out of the bracket. Okay, it's as good as saying having the negative. When we take the negative sign out, it actually becomes positive because of this square. If this square was not there, there would have been a negative sign outside. Okay, and when we take a negative sign outside from here, what is positive becomes negative, what is negative become positive. That is why sine a is become positive over here, and cos a, which was positive, became negative. And when it turned into sine a minus cos a, we could cancel this 2, and we were left with only sine a upon cos a, which we needed. Okay, so if you have liked watching this video and the other videos, please click on the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notification whenever new video is posted. Thanks for watching. See you in the next video.